Schematic diagrams with graphical symbols are used to show the electrical connections and functions of a specific circuit. This line or ladder diagram shows various electrical components interconnected by lines. These lines are arranged like rungs on a ladder. In determining the operation of an electronic circuit, it's important to consider whether a switch functions manually or automatically. Manually controlled components require physical manipulation to work. Automated components turn on and off without manual intervention. A typical example is a float switch found in a sump pump. When a rising water reaches a certain level, a float switch is activated that turns on a pump to expel the water from a tank. Another important aspect of any circuit is to determine the coordinated manner in which control devices, such as push buttons and switches, function to operate a circuit. This is known as control logic. Combinations of switches and buttons can be configured to conform to the rules of basic logic functions. Let's look at several examples by exploring the functional relationships of various switches in this diagram. The first control logic we will look at is AND logic. AND logic is present when there are normally open control devices connected in series. Here we have two automatic switches. The motor coil M2 will only be energized if both floating switch 1 and temperature switch 1 are closed. Next, let's consider OR logic. This can occur when there are two normally open control functions connected in a parallel arrangement, represented here by two start push buttons. Thus, motor coil M1 can be energized by manually pressing start switch 1 or start switch 2. With M1 energized, another type of control logic is exhibited, called memory logic. The energized M1 coil will cause the auxiliary contact M1 to automatically close. Therefore, even after the start button contacts are opened, the starter coil will continue to be energized due to the closed position of M1. There is also control logic associated with normally closed switches. NOT logic occurs when there is a single normally closed switch in a circuit. Thus, when the normally closed switch, stop 1, operated by a manual push button, is pressed, the M1 coil is shut off, and the M1 holding contact is deactivated. NOR logic, an extension of NOT logic, operates by the inclusion of a second normally closed push button in series. In this arrangement, pushing stop button 1 or stop button 2, the M1 coil is shut off, and the M1 holding contact is deactivated,